Hey everyone, so we're going to continue our work in solving matrix equations. You can see there in the instructions. This assignment, we're not going to have to worry about no solution. I don't think it comes up. Well, let me check the answer key. Yeah, oops, okay, never mind. State if there's no solution. All right, we'll talk about that when we get there. Okay, so what we're looking at here is a matrix times our variable. Remember, that also stands for another matrix, equals a matrix. So we're supposed to solve for capital Y. In regular algebra, that'd be something like this. 2 times y equals 8. Of course, you'd solve this by dividing both sides by 2. 4 would be your answer. With matrices, we run into an issue because what you're going to want to do is divide both sides by this matrix right here. And as it turns out, mathematically speaking, this is absolute gibberish. There is no such thing as matrix division. It's just not an operation that exists. So instead, there's a slightly different way to work this out, but I think when you see it, it'll be fairly intuitive. It'll make sense. So here's what you do. The thing that you want to cancel out, the matrix you want to cancel out, you multiply on the other side. But what you multiply by is called the inverse of the matrix. So it's not dividing, it's multiplying by an inverse. Now, when it comes to finding the inverse of a matrix, it's kind of like a determinant. There's this step-by-step process to work it out. If you remember, I showed you how to multiply diagonals to do determinants. So inverses, there's a whole other process for doing that, and you can do it by hand. But we're just going to use the matrix calculator to do this. So when it comes to answering a question like number 2, like actual, do it, finish it off, I need to first enter in 2 matrices. So I'm going to hit new matrix. It's 2 by 2, 7, -3, -8, and 2. And then matrix B, new matrix, add 21, -14, -14, 26. Then on the next line, I multiply A inverse times B. So A inverse times B. And we end up with a matrix 0, -7, -5, -7. Let me scroll down to the answer key. Oh, and there it is right there. So what your instincts tell you that there must be some way to divide this matrix to isolate the variable, not exactly right. You actually multiply by the inverse. Now, I do want to show you something. Here, I'm going to move this over, give myself a little room. I'm actually going to redo the problem and just, here. I'm going to type into the calculator this. I'm out of room. Doggone it. Shrink this down a little bit. It's the sort of thing I'll probably erase when I'm done anyway, so it doesn't make a big deal. So I'm going to do matrix B by the inverse of A. And that's easy to do on this calculator because I already have the matrices typed in. I just do B times A inverse. And notice that gives me a different answer, and it's the wrong answer. So order matters when you type this in. It turns out that A inverse times B is not the same as B times A inverse. So that's a little bit counterintuitive. With regular numbers, we're used to something like 2 times 3 equals 3 times 2. With the order you multiply something doesn't matter. But remember that multiplying by an inverse is kind of like the matrix version of division. And if you take something like division, 10 divided by 2 does not equal 2 divided by 10. So order is important. So as a general rule, I'll write this up at the top so you can jot it down also. When you do these, you're always going to want to do the inverse times the matrix. The inverse goes on the left, or it goes into your calculator first, or however you want to say that. Okay, let's do number 4. Sometimes a little bit of repetition is good. So if I want to solve for x, x is going to be the inverse of this matrix that goes on the left times this matrix. Now it's a little tedious that I have to type these into Desmos, but it's much nicer than doing all the math by hand. So there's that one. My next matrix is 2 rows, 1 column. So that's -10, -20. Hit enter. And now I need to do, again, A inverse times B. Now you see the little orange warning triangle down there? That means that there is no solution to this one. So no solution can happen. There is no matrix that makes this equation work out. So it doesn't say undefined or error. It gives you that little triangle thing. And just to triple check, yeah, no unique solution. We'll just write no solution. That's fine. Okay. So here is where it, well, I think it gets interesting. You may not care at all. So Gaussian or Gauss-Jordan elimination for systems of equations. This is the thing you probably have hated most so much, is that row echelon elimination. So if we were to follow the directions here, I say if because we're not going to, but if we were to follow the directions, we would set up an augmented matrix like this. Then we'd go through a bunch of steps, ... until we got to 1, 0, 0, 1. And then whatever's over here are the answers. Maybe I shouldn't do circles, but whatever's over here are the answers. So you remember that? We did like 2 days of this. There's a day where I kind of screwed up the notes or the video, and it didn't go that well. And even if it had gone well, you probably didn't enjoy it. Well, here is something kind of beautiful. This system of equations, there's another way to express it, and it's like this. Okay, what is that? That is a matrix made out of these coefficients. Then, next to it, you put xy. xy is these two variables. Then you put an equal sign, and over here, put -4, 2. Oh, and by the way, when you have a matrix of all variables, if you want, you can just call that x. Or if you don't want to use x because there's already an x up there, you could call it A. Or maybe you don't want to call it A because over here we're doing A and B. So maybe we'll call it M for matrix. Yeah, I like that. Capital M. Can we solve this? We sure can. We just learned how. M is going to equal the inverse of this matrix times this matrix. So go over here, and I can actually just edit what's already on the screen. So there's the 2 by 2 matrix. This one's going to be -4, 2. And there we have M equals -1, 0. Or if you prefer, you could say x equals -1, y equals 0. Or you can make it a point, -1, comma 0, however you like. But this, with the calculator, replaces all of that row echelon elimination stuff that was awful. Let me not make a fool of myself. Check number 6. And there we have -1, 0 right there. So look at number 8. Again, I don't want to give you a complete nightmare, but if we were to do this the hard way, this is what it's going to look like. I had the graded notes, if you remember, where I worked one of these out, and it took an entire page of work to get this down to the point where we were done. I don't know what's going on with my writing, but you're used to that. Okay, so this is the worst case scenario. You're going to have to solve this using row echelon or Gaussian or Gauss-Jordan elimination. There's all sorts of names for it because all sorts of mathematicians were in on it. But we're not going to do that. We're going to look at it as an equation. So We have a 3 by 3 matrix. -2, 3, -3, 1, -2, -4, 0, -4, -4. That's multiplied by a matrix called XYZ, but just for simplicity's sake, we'll call it capital M for matrix. Then over here is 2, -16, -16. The solution then is to multiply the inverse of the big one times the little one. Give me just a second to write this out. Okay, so I got to type that in. Let me just clear this whole thing. So add a matrix. The first one is going to be 3 by 3, and that's -2, 3, -3, 1, -2, -4, 0, -4, -4. The biggest potential problem here is typing in something wrong or writing it down on your work wrong. The calculator does all of that awful work. Oh, you have to hit new matrix. This one is a 3-row, 1-column, 3 by 1. And so that's -2, -16, -16. And I need to do A inverse times B. And what do I come up with? -2, 1, 3. I'm writing it this way because like an XY, oops, like what we call an ordered triple XYZ. Since our answer is a solution to the system of equations, unlike up here where we're just looking for a matrix solution, it's the same process, but you write the answer slightly differently. And there it is. So let me do a brief recap here, just in case anything was confusing. What we're focusing on is solving a matrix equation, just like yesterday. The thought is you've got a matrix times a variable, so you would want to divide the matrix over to the other side, but there's no such thing as matrix division. Instead, you multiply by the inverse. You could find the inverse by going through this set of manual calculations, but it takes a while and the calculator does it for you, so we're skipping ahead to the calculator. So you have the calculator do this work and it spits out the answer. You have to do the inverse on the left, the regular matrix on the right. If you do it the other way, it does give you the wrong answer. Then we apply it to problems that we've worked on before that were just a nightmare, and it turns out that on the calculator it's not a nightmare at all. It's pretty simple. So this matrix are the coefficient numbers. M just represents your XY or XYZ. Just use M as a variable. And then this matrix over here are those two numbers. Once you have this set up, and it's pretty easy to do, it's the same process as up here. And then when you get your answer is going to be written like an ordered pair or an ordered triple instead of being written as a matrix like that. Okay, I hope this made sense. Your assignment is only 4 problems long. Contact me if you have issues through messaging or email. And then tomorrow, Wednesday, I'll have open office hours, so I can jump on to Google Meet with anyone and I can share a screen and I can talk through and work out problems just like if we were, I was tutoring you one-on-one. So keep that in mind if you have any trouble, but do your best on this. Check your answers, turn it in. Good luck.